Alright, today we're working on section 3.5, linear equations in 3 dimensions. We're going to be graphing points and linear equations in 3 dimensions. So points is just going to be a point on a graph, and then a linear equation, actually when you're in linear equations in 3 dimensions, we're going to be graphing a plane. We have 3 vocabulary words, a 3-dimensional coordinate system, what an ordered triple is, and an introduction to our x-axis. So here we have a hand-drawn 3-dimensional coordinate system, and then the nice one that I cut and pasted out of the book. If you see here, the x-axis is coming straight out of the computer screen at you. It's facing at you. The x-axis is no longer, over here with the y-axis up here. The x-axis comes straight at you. The y-axis goes this way, and the z-axis goes up and down. So I've drawn that right here. Our y-axis, positive y, negative y. Our z-axis, which is positive z, negative z. And our x-axis comes straight out at us. Pointing towards our face is the positive, and pointing towards the back is the negative. The origin is 0, 0, 0. That's your triple pair, ordered triple. It's called x, y, z. Let's try an example. Example 1, graphing points in 3 dimensions. Our ordered triple is x, y, z. It used to be an ordered pair, just x, y. And what I usually do is take a regular 2-dimensional system and draw a diagonal line where this is positive, this is negative, your x-axis. So we're graphing a point in 3-dimensional space. A is 3, negative 2, 1. So your x is 3, your y is negative 2, and your z is 1. And the best thing to do, let me get a different color here, is to start at your origin and start going 3 in the positive x direction. 1, 2, 3. Okay, and stay there and go negative 2 in the y direction. 1, 2. And then go 1 in the z direction, right there. So that is A. Okay, we went 1, 2, 3, positive x direction, 2, negative y direction, 1, positive z direction, and that is our answer. Let's try another one. X, Y, Z is 2, negative 1, negative 3. We start out at the origin, and we go 2 in the positive x direction, 1, 2, 1 in the negative y direction, 1, and 3 in the negative z direction, 1, 2, 3. And then you're just going to label it B. Another one, negative 1, 0, 2. We always start out at the origin. I'm going to go negative 1 in the x direction, back that way. Let's try that again. It's sort of messy. Negative 1, 0 in the y direction, and then 2 in the z direction, and label it C. Okay, you try this one. Please push pause and try on your own, even if you're just figuring out on your computer screen where it might be. Okay, I went positive 1 in the x direction, negative 3 in the y direction. I'm sorry. Let me start over. Positive 1 in the x direction, positive 3 in the y direction, and negative 1 in the z direction, and got D. Try one more. Positive 1 x, negative 3 y, positive 1 z. One more. And that actually should be labeled F, not E. Alright, so a graph of linear equations in 2 dimensions is a straight line. In 3-dimensional space, the graph of a linear equation is a plane, because a plane is defined by 3 points. You can graph linear equations in 3 dimensions by finding the 3 intercepts. If we're looking for the x-intercept, we set y and z equal to 0 and solve your equation. Y-intercept, we set x and z equal to 0. And the z-intercept, you set x and y equal to 0 and solve for z. Let's try one. Graph a linear equation in three-dimensional space. Graph the linear equation 2x minus 3y plus z equals negative 6 in three-dimensional space. So let's find our x-intercept. So we have 2x minus 3 times 0 plus 0 equals negative 6. I apologize, I've left my pen at home. So I have 2x equals negative 6, x equals negative 3. Y, 2 times 0, set x equal to 0, minus 3y plus 0 equals negative 6. Divide both sides, that's gone, by negative 3. Y equals 2. And z, squeeze this in here. 2 times 0 minus 3 times 0 plus z equals negative 6. Z equals negative 6. And we can go ahead and graph that. Now we're graphing the points. So let me get another color out here. For x, it's negative 3, 0, 0. I'm going to go negative 3. 1, 2, 3, and put a point. For y, it's 0, 2, 0. So I'm going to go 0 in the x direction, positive 2 in the y direction, and 0 in the z direction. And for z, it's 0, 0, negative 6. 0, 0, down 1, 2, 3, 4, 5, 6. And our plane, this is where you need to get out your ruler. Let me get a straight edge of some sort. It's hard to do without a pen. And you're making a triangle. This is going to be impossible with my finger. Goodness. You're making, oh, for goodness sakes. You need to make a triangle, and I do apologize. You're connecting all your points. For this one, it's awful. Let's try that one more time. 1, 2, 3, point. 1, 2, and negative 6. It still isn't going to be a very good triangle. Okay, we'll do one in class tomorrow. Okay, let's try another one. For x, so now we're finding each intercept. Our x-intercept, x minus 4 times 0 plus 2 times 0 equals 4. Gone, gone, x equals 4. Our y-intercept, set x equal to 0, set z equal to 0. Okay, gone, gone, divide by negative 4. Y equals negative 1. And our z-intercept, 0 minus 4 times 0 plus 2z equals 4. Z equals, excuse me, z equals 2. So we have x equals 4. 1, 2, 3, 4. Y equals negative 1. And z equals 2. 1, 2. Okay? Not much better of a graph. Again, you're making a triangle. You're connecting the points, and that shows your graph. Okay, you try this one. Find your x, y, and z intercept, and then try to graph it in your notes. Okay, your x-intercept, your y-intercept, and your z-intercept. I plotted them, and this triangle signifies your plane. Your plane would travel through each of those points. What you see here is the triangle that you just graphed for the U-Tri with a plane drawn through. I hope this helps you visualize it a little bit better. You have your x-intercept at negative 2, your y-intercept at negative 4, and your z-intercept at 6. which you would draw a triangle, and that's what I'm asking, and that signifies the plane that passes through all those points.